And in person. I'm Matt Allard, and excited to be here today talking about golf and Raspberry Pi, of course. So quick show of hands, who here is a golfer?
I've golfed.
You've golfed. Okay, good.
Yeah.
Okay. Well, even if you haven't golfed, you probably know who this guy is. So what I'm going to do today is just talk a little bit about the why, and then I'm going to talk about the how. Okay, for Puttr, which is a company I started during COVID. So it's a COVID baby. So everybody knows this guy, Tiger Woods, 25 years ago, came on the scene, made golf much more popular than it was then. And COVID made golf even more popular than it was in 2018, because you could socially distance and golf at the same time. Quick numbers, I'm going to throw some numbers at you. Last year, 25 million people in North America played on-course golf, but 28 million people played off-course. So more people played off-course. And what that means by off-course is they played either at a driving range, which if you've heard of Topgolf, you guys have heard of Topgolf, or they played in like a simulator bar, which they're all over London now. There's a million of them, but they played where you basically hit into a screen and then it shows you where the ball goes, and usually uses Doppler or some other technology. Quick primer on golf for people who don't play. There's really two main shots in golf. There's like the full swing, which is what you do at the driving range, right? A lot of fun, hit the ball. And then once you get on the green, you putt. And you putt with one club. It's called a putter. And actually over 41% of all golf shots are hit with a putter. So it's kind of like the chef's knife of golf clubs. It's the most used club in the bag by far. However, no one really practices putting because it's incredibly boring up until now, right? And so during COVID, I had my son who was about 2, almost 3 in COVID, and I take him in the backyard and he would just whack balls all day long, right? And again, apologies for the portrait mode video, but he would just hit one after the other. But I really wanted to get him into golf. And the way to do that is really start on the green and at the hole and work backwards with putting. So I Googled best home putting mat, and this is what we got, right? So, basically the home putting mat or the home putting experience hasn't evolved at all in hundreds of years. It's basically a piece of carpet with some holes in it. And some people will go and do like a full build out in their house where they build a full green. But that was not available for me because I'm married.
You want to stay married.
I want to stay married, exactly. So, so I was like, there's got to be something more fun that I could create. And so my background is in software. And I was running a mobile app startup at the time. And so I said, you know what, I'm going to start tinkering with a Raspberry Pi, and I'm going to retrofit this home putting mat that I bought during COVID so I get some sort of feedback and gamification, right? Are we making putts? Are we missing putts? As our last presenter talked about, I started with GPIO. And I started, this is my very first prototype. So you can kind of see here, little iPad and the green. Now, what's in each hole is a piece of screen that I got from Home Depot, a piece of tin foil, and then I basically just cut a paper cup and put a little bit of separation between those two things. And then wired each one to a GPIO. And so when the golf ball landed on the screen, it would complete the circuit, right? And that would tell me if the putt was being made or not. So here's my little lame demo that I had way back when. So you could tell when the ball actually went in the hole. Now, the problem with that is you don't know when you miss. There's no data for the balls that don't go in. So I said, all right, let's get to our next prototype, which I was like, all right, let's use brake beam sensors. So I said we could put, real cheap. I could put a brake beam sensor in each hole. So when the ball's sitting in there, it's blocking. But also at that front of that little ramp, I could put another brake beam. So I would know when the ball starts up the ramp, have some timing, And now I would know if within, let's say, 2 seconds, there's no brake beams in the hole, you missed the putt. So I started working on that, and what I realized is the problem with brake beam sensors is the sun. The sun actually is infrared light, if in case you didn't know that. And so when the garage door was closed, the prototype worked really well. But if it was sitting in front of a window or if the garage door was open, the prototype did not work very well. So then I took the big leap, so to speak, and got very ambitious during COVID and started messing with OpenCV and computer vision and started using a Raspberry Pi camera. And that's what that's where I ended up. And so I started with a standard camera, but the problem with a standard camera is the view angle. And so I found these wide angle lens cameras that I ended up with, which are under $10. And so this was my next prototype, which I won't show you the video, it's awful, but I basically built a prototype out of wood and to get all the numbers dialed in before then ultimately going to a contract manufacturer in Shanghai and building the product, launched an Indiegogo in 2021. So now I'm going to kind of take you through the product and like how it works and how it uses the Raspberry Pi and computer vision. How do I just go to the next slide? Okay, so this is what the product looks like. It's a box. And one of the big problems with these home putting mats is they're very ugly. They're fluorescent green. And so again, I'm married. And so I would roll it out, and then every night my wife would be like, all right, put that thing away. And so one of my design goals was to make the box look like a subwoofer or something that is kind of cool, and it has the carpet would roll into it. The door would close. It's magnetic. So you can put it away pretty easily, and it's not a total eyesore. So it could sit under the bench or sit under a table and not be like the ugliest thing in the room. The other thing is the carpet itself. It actually, with the slope of the ramp, which is about a 12-degree slope, each distance has 3 tees. And so that gives you a left to right putt, a straight putt, and a right to left putt. Most home putting mats are just a straight putt. So it's going to give you a better practice opportunity with 27 different looks than just a straight putt every time. But now that I have the computer vision tracking the ball about 80 frames a second, I can not only measure makes and misses, but I can actually calculate the speed of the ball based on the differential in the y-axis at a given frame rate. And then I can also measure the entry angle to the hole. And I'll get a little bit into that. But for golfers, that's actually really important because you want to, when you start really practicing, you want the feedback, as much feedback and data you can get on what the ball is actually doing when you're practicing. Right now we have like over 100 games. So it's also like meant to be like an arcade where we have beer pong, we have horse, match play, metal play, all these different games to just make it fun for people to pop. And then you get a profile. So you get all your statistics, all the percentages from each distance, make percentages, and all this data that actually helps you become a better putter. And we give you the community. So you can actually play putter online against anybody else with a putter. And so we have, well, it was Twilio, WebRTC video. Now that they sunset that, so now it's going to be Zoom, WebRTC video. But you can actually play live against people, and you just stick your device, whether it's iOS or Android device, on top of the box, use the front-facing camera on the device, and you can actually play people live. So now getting into the Raspberry Pi stuff, that's the why, and now the how. So the first thing it does is it actually will detect where the hole location is on boot. And even though I'm mass manufacturing this product, believe it or not, with injection molding and everything like pretty dialed in from a mass manufacturing perspective, you do get every single camera to hole is slightly different. And when you're looking at a 640 by 480 pixel, which is the lowest amount of pixels I can look at right on the camera with any kind of accuracy, you have to detect the hole every time, because if you don't, it will be slightly different, and that will impact the accuracy on measuring what is a make and a miss and the entry angle to the hole. So I'm using a Hughes algorithm for actual circle detection on that. Now, that's a really good algorithm for detecting circles in computer vision. The problem is it can do about 1 frame a second tops on a Raspberry Pi 4. I haven't messed with it. I have a 5, but I haven't messed with it yet. And so that's done at boot, and then it just saves. It's not going to move once it's up and running. So it saves that onto a flat file, and then the app knows where the hole is. Then after that, it's actually running at about 80 frames a second, and it's using an HSV color spectrum. So I'm basically converting the image to black and white. I'm blurring it. I just like a standard Gaussian blur, which is a standard OpenCV library. And then it's finding contours. And that's actually how I detect the golf ball. And so my carpet and my hole, like obviously underneath the hole, it's black, and the carpet is like a dark green. But it finds the coordinates at 80 frames a second of a golf ball when it enters the ramp, and grabs the X, Y position of that contour and the radius of it. And on exit, which basically means it went in the hole, it went past the hole, or it came back down the ramp. On exit, it then throws that up to Bluetooth, and the app receives it and then processes it. And so this is kind of a big version of it, but here you can see this is just a random 8 putts that you can see on the screen. So the green ones are the ones that went in the hole. The red ones are the ones that missed the hole. This one was short. This one went around the back lip. This one made it on the left side, right side. So you can see the ball data. Okay, so that's how it works. And now for people working on this kind of stuff, whether that's computer vision side of it, Bluetooth side of it, peripheral side of it. Now I'm just going to kind of go over some gotchas that I lost some hair on, and so maybe I can save people some hair. I also use text to image generation for all these slides, so if you have any feedback, would love to hear it on the Dolly slide. So this is an apple battling a Python. And the reason I did that is that iOS devices with a Bluetooth peripheral do not play that well together and are actually pretty annoying to get to work consistently. All the computer vision stuff I've done is in Python, but Bluetooth connectivity uses Blues is kind of the go-to library for Python Bluetooth connectivity. The problem there is that my application, or my device is headless, right? And so I don't have a screen like in a car where you get a pairing code. And with iOS devices with a Raspberry Pi Bluetooth peripheral, it would always prompt you to match a pairing code, which without a screen you cannot do. However, Belino, which is a node-based Bluetooth package, works very well with iOS and Android. Well, and by the way, Android always works, even with Blues, but iOS does not. With Belino, though, however, with Node, it works really well and very consistently. So again, just kind of a gotcha for people building or using Raspberry Pi as a Bluetooth peripheral. And primarily as a GAT notification server. I won't get into all that detail, but it also doesn't appear under Bluetooth settings. So like my app, which is written in React Native, connects directly to the Pi with a known Bluetooth name. And you'll see it in like BLE Scanner or any kind of Bluetooth application. But if you go to Bluetooth and the settings on your iPhone, you will not see the device. On Android, you do. On iOS, you do not. I'm deep in the basement of Stack Overflow to figure out why that is, and I really don't know. So if anybody knows, I don't really haven't found a good answer online for why that is. It has something to do with, some Apple thing. So what I did to solve it was, because ultimately for performance, you need to send the ball path up from Python. So I'm sending it up via Socket.io to a node socket server on the Pi that I'm running that then sends it over Bluetooth. So that was the way I solved it. And it works. There's no, obviously, network latency because it's localhost. So that worked pretty well. The next gotcha was headless Wi-Fi configuration. And so I don't know if anybody's experimented with this, but basically I want to connect my Raspberry Pi to any Wi-Fi network without a screen and without being able to take out the SD card and throw the WSA supplicant on to the SD card, right? So if you search, and again, been deep into Stack Overflow on this one, but if you search how to do a headless configuration, the only one I've really found, which unless it's been updated in the last, I don't know, 6 months to a year, does not work on the 4. On the Raspberry Pi 4, works only on the 3. But the headless Wi-Fi configuration package that's out there uses Wi-Fi, right? It does not use Bluetooth. So basically, it sends out, it creates an SSID off the Pi. You take your device, you connect to the Pi. It serves up like a flat HTML file that you then put in your SSID and password, and it sends that over Wi-Fi. Then you disconnect your device, and the Pi reboots and connects. But that was not a very elegant solution. It also didn't work on the 4. So what I did, and I also do not have this in Git. Happy to put it up there. I just haven't had time. But if people want this code, happy to put it into Git. What I basically did was I just wrote a Bluetooth read and write. So you run the Bluetooth peripheral on the Raspberry Pi. You then can write your SSID and password over that. It sudo overwrites the WSA supplicant on the device and then sudo reboots. And also you obviously have to do that in sudo. So I use PM2 as my package manager, so I'm always running that file in sudo. But that's how I'm doing it. So it's a Bluetooth connected headless Wi-Fi setup. You obviously have to build your own front end or interface for the Bluetooth connectivity, but it works. The other gotcha there is the buffer length on pretty much every device, Bluetooth device, is different as far as what its capacity is to send. And it's actually surprisingly very small because it's BLE. And so the code also does this, but you basically have to break down, and like, depends on how long your Wi-Fi password is. Mine's very short, but like my parents have a very long one. You have to break that down and then reassemble it on the Pi, right? Because and send it in multiple packets. So that's, again, just kind of a gotcha that you wouldn't expect, or I wouldn't expect, but that's a limitation of Bluetooth. Is it's like 48 characters, I think, on most devices. Okay, another very niche gotcha. But if you are developing an app in React Native, which is a very popular app development framework, and that is also what I use to build the Puttr app. If you're connecting to any type of hardware peripheral over Bluetooth, that blocks the native layer. And what I mean by native layer is, and sorry, it's out of scope maybe for Raspberry Pi talk, but React Native is a JavaScript library, and then it compiles up to Objective-C or to Java on Android. But whenever there's communication between your code and the actual app, right, it's using a layer. It used to be Cordova, if you guys are familiar with that, but now it's React Native, but it's blocking. And so what I mean by that is animations, like, so if you want when the temperature goes up on your sensor to animate the thermometer, let's say, or in my case, you want, when the ball goes in, you want to launch a rocket. It won't work with native animation on React Native. And so again, very weird and obscure gotcha, because it works perfectly in testing, but then when you actually connect the real device to the peripheral, it just doesn't work, and you don't really know why, and there's no warning or errors happening. It just doesn't work. And so it's at the native layer. And so there's this great package called React Native Reanimated, which is well maintained, and it uses the UI layer for animation. So if you are doing animation and connecting to a peripheral, you have to use Reanimated. And so I would highly recommend that. And that's Bugs Bunny being blocked in football, is what I was saying. Okay. And then the last thing, I think this is my last one. Yeah. My last gotcha was shielding. So, obviously with a camera, you're using a cable. Let me just see if I can, I can get out of this. Go here. So this is, if you look up in the box, right, in the Puttr box, there's this piece of plastic, right? And this is where, so back here is where the PCB sits, and then runs USB. This is the Raspberry Pi mount, runs a cable here to power the Pi, and then it runs another cable to power the light, the LED light. If you do computer vision applications, lighting is very important. And then the cable for the camera runs here. This is the camera mount, as you can kind of see here. And then this is like the little blocker, so like light doesn't get in, and it doesn't have tons of false positives and noise. Got some vents here too. But the cable runs over the top of this. Now this is plastic, and then I completely cover the cable in tinfoil and rubber. But despite all that insulation, different LED lights will create noise on the cable. And so it's, again, one of those things that, depending on how good your testing is, but when you're a startup, you don't typically have like a big testing department. So one of the gotchas is to always be checking your video signal when writing OpenCV or any computer vision code. Because even in an environment where it's very controlled, you can experience noise. And if you have any noise and the video signal is not perfect, your computer vision, obviously, software won't work. And you won't know why. And so, especially because I'm using a very stripped down, I'm not sitting here looking at a live video, I'm converting it all to XY coordinates. So I'm just looking at like the matrix basically, and it's not very clear when that noise happens, and it's intermittent. So long story short, always check your hardware and check the video source and look at raw video or stills, depending on what your application is. But constantly be doing that, because depending on the environment that your Pi, the camera, is running in, you can get a lot of noise on the cable. Cool. What's that?
The cable you're using shielding.
Oh yeah.
Yeah.
Even with that, it's
yeah.
I mean, like I said, I wrapped it twice, and it's sitting. There's a plastic, like a thick plastic between it, and still just with different LED, like with lighting at least, that was my experience. There's noise on the cable, even with it completely shielded and wrapped. I mean, I wrapped the whole thing, even the Pi, like everything.
The shielding is earthed at each end.
What's that?
The shielding is earthed.
Yeah. So, and our manufacturer actually changed some of the specs on the LED light, and now it all works great. But but yeah, it might have been an issue with leakage on the LED. I'm not really sure, but ultimately it affected the application. So just a gotcha to look out for. Yeah.
Does LED provides stable light, or it's blinking light?
In here, it's a stable white light.
Like when I see like stable light, but it's can be 50 hertz or 60 hertz. So in this situation, when the light could be like the light signal was really disrupted by just because it was not that you see by your eyes. Camera see absolutely different. It came from the dark moment of time.
Yeah, I mean, it was like just giving me like complete static on the video feed.
It was forwarded from battery or from
What's that?
a device forwarded from battery or from the.
It's powered from a wall outlet. Yeah, it's not a battery.
So what's your interface to the event? So the Raspberry Pi sends what, just hit or miss, or it sends all the data as well?
Yes.
Going.
So it basically sends the complete ball path over Bluetooth up over the GAT server to the app.
And the your application just has just a user and do you have like the app just explains the app? Just wonder what the app actually looks like. If you choose games and you log in like a normal app, I suppose.
Yeah. I don't have it. I mean, I could run it, but I mean, I could show it to you right here. Yeah.
I just wonder what the basics are like. If I'm a golfer, I would say I'm a good golfer, just for the stretch. Say I'm a scratch golfer. I wouldn't want to challenge anyone on your app. So do you actually have do people end up with handicaps and stuff like that? How do you like group the golfers, or do you like everyone has their own little community? This is like a good community, and these guys don't know what they're doing.
Yeah, typically, so there is a handicap, and we do handicap matches, so you can actually, it will make the better players have to make it at a tighter entry angle to the hole than the worst players. But yeah, typically it's like there's the online tournaments for everybody, the public ones, and then there's private ones, which are usually like friend groups of people playing with their friends who they golf with. Yeah.
But all you can see happening is a virtual ball going into a virtual hole. You don't actually see the other person or their putting mat or anything, do you?
Yeah, you see the full person. Yeah. So basically you have the you have like, let me just show you like here, right? So you have the iPad, if you can see here. The iPad is on the top of the box, and the front-facing camera is enabled during the game. So you're basically seeing the person putt at the camera, and vice versa.
Okay.
Yeah, yeah. And then the replay of the ball data, like going in or whatever, is overlaid on the screen on the interface, and then the scoreboard. Well, thank you. Is there any? I don't know if there's. It looks like there's some chats. Do you want me to look at that or?
Yeah, there's
basically use Python for OpenCV and Node.js for sending stable Bluetooth data via Bluetooth.
Yeah, it's I'm using Blino package in Node for the Bluetooth, and yeah, OpenCV for Python for the computer vision.
Good, just people send love in any location.
Yeah.
Especially in that moment.
Yeah, how to get it to work.
so how many of you sold? How many are out in the wild?
Yeah, so we started shipping in January of last year, and there's just almost 2,000 now in the wild. Yeah. So we've got so we're making good orders with Raspberry Pi, which in 2022 we were in a panic for the first half of the year, and contacted everybody through LinkedIn. Thank you, Samantha Snyder, for coming through, and so got some Pis. So yeah, we're using a 2 gig 4 right now. So hopefully they keep making those.
How do you maintain your application? How do you change the stuff that's on everyone's Pi, or you just can't?
Yeah, great question. So that was actually one of the big reasons why I created the headless Wi-Fi configuration. So once they connect their the box, so for like out of the box, they don't connect it to their Wi-Fi. There's no need to unless we need to do remote support, which we don't really have to. Most of the updates are going out over the app, over the air. However, there's a really cool tool called Mender IO that we've used for commercial setups where we have like in a place, and then we have it connected to Wi-Fi. But yeah, once they connect it to Wi-Fi, like with Mender, we can literally command line it and SSH. Yeah, and then in some cases, depending on like their network setup, we'll like even do TeamViewer and then like SSH locally.
What sort of reliability are you getting constant calls from people versus?
No, none. Yeah, yeah. So I run all the support too. So we use Zendesk, and yeah, it's the one thing is using pink golf balls doesn't work too well. So anybody out there use it? It's white or yellow golf balls right now only will work well. Pink again because I'm using the HSV, which is a cool thing with computer vision, but again, it's about stretching out the best frame rate possible out of a Raspberry Pi device with computer vision, right? If I had like a full Mac, you could run like full object detection and do all kinds of cool OpenCV stuff. But yeah, with a Pi, you're a little bit limited on frame rate, depending on how you're doing it, what methods.
Over severe updates for application and for software or
Yeah, that's what I was just saying. Yeah, it's all over the air. Yeah.
Yeah. Last question.
Yeah.
This host, are they just drawing like picture or a real host that host nice?
Oh, it's a real hole.
I was wondering who makes this for mechanics feel?
I kind of got I went on edX and got like a freshman course load on industrial engineering from MIT and just basically taught myself 3D and did it myself.
Oh, okay. I
Yeah.
design the whole.
Design the whole thing. Yeah.
Oh, brilliant.
Yeah.
Oh, okay.
Yeah.
So goes into the hole and after several seconds it will pop up and going down.
So no, it actually, and here, let me just see if I can.
It stays in the hole.
No, yeah, like it's here, let me see. We can go so like it's a real hole. And so it goes, so there's a trap door back here and it goes in the hole and then it all comes back down here and this is a ball return.
Oh.
Yeah, yeah. So yeah, it's real, there's no attachments, no special balls. It's a real golf ball, real hole, real putter. You just
the gravity.
Just gravity, exactly. Everyone says, why do you need a ramp? And I say gravity. That's always my answer. So yeah, I mean, unless you want to cut a hole in your floor, I guess you could do that too. But yeah, I mean, you roll it up and then the door closes and it's magnets. And that's it. The ball return also is magnetic. So it just click, 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 and you put it back in the box. And so everything fits in the box ready to go. And then the power cable, which just goes in the back.
So is that an existing piece of kit then, and you attach your box to it, or?
No, I built the whole product. The whole product is us.
Wow.
Yeah. So and inside the box here, like right there, you can see that little lip. That's where the Pi and the camera is. It's inside of the top of the box.
The green mat and everything. You built all that.
The whole deal. Yeah.
Wow.
Yeah.
Where's that manufactured?
Yeah. The product itself is manufactured in Shanghai, and
Right.
the carpets are actually made in Shenzhen.
Oh, okay.
Yeah.
Wow.
So.
Big operation, isn't it?
Yeah, it was a lot of time during COVID.
Yeah.
So I must have to learn a lot of new skills.
Yeah, I mean, I'm a software guy, so like even like some of the Bluetooth stuff might sound stupid to some of the smarter people here. But yeah, I just kind of had to make it work. But definitely industrial, the industrial engineering part of it and kind of 3D part of it was definitely a big learning for me. And then all the prototyping I was just using Craft Cloud to 3D print and send it to myself during COVID. And so, but now the 3D printing now is like fairly cheap. But I'm not like a material science expert. So all the different plastic options, like the ABS and PET, and then there's like 20 different versions of PET, density, thicknesses, and that kind of stuff, was definitely a learning curve. So yeah.
How did you market it? How did you sort of go about marketing?
Instagram.
Oh, okay.
Yeah, just basically Facebook Business Manager and Instagram is how I did it. And then we did an Indiegogo in 2021. And then, as we all know, had the chip shortage in 2022, the great chip shortage of 2022. And then, yeah, and then that's primarily how I'm marketing it now. And then we've had a lot of media last year. So it's been going really well. Yeah. It's been a lot of fun. Thank you. Cool.
Do you check for regulation ball size being used?
Well, that's a good question. I haven't really checked the radiuses. I mean, I have all the radius data, so I technically could. But no, I don't know that using a bigger or smaller ball would be an advantage.
Very broad company.
Yeah, well, it's right now it's all free. I mean, there's no like you can win a prize in the tournaments, but you're kind of only hurting yourself. I mean, most of this stuff is for practicing, for golfers who want to practice. So yeah, I don't know that ball size would.
Guarantees aren't achieved.
Yeah, well, so one of the cool things now with the new Pi is the 2-camera interface. So that I'm pretty excited about. I've already got one, and I've gotten the connector cable, for that input. And so the concept now is to actually put the second camera here on the front of the box. And right now I'm using the device camera. So like you put the iPad on top or whatever, and then I just use that front facing camera, and then I record the video from WebRTC, throw that up to Google Cloud, and then I will, you can transcode it. So I get your, all your mechanics, right? Your posture, your eye line and everything. But I could do that at the edge with the Pi. So you could actually be live body tracking. I haven't found a good library to calculate object distance. Because again, everybody's body is a little different. And so it'd be hard to figure that out. However, once we have that up and running, it's kind of like the Tesla effect, where you could have enough data to train a model and probably get a really good ML model to determine body distance from camera. Because right now there's no way to do it with like focal properties, but
You use carpet. Yeah, use the carpet, you can put some marks.
there already is marks. So that's actually a good point. Yeah, I mean, it's just, if you really want to make hardcore cheating impossible, you can have one guy standing there and then another guy like this, so I'm trying to get it to I can detect any object and do it at the edge. And so I'm excited with the new 2-camera.
I've started having a bit of a play around with the 5s. I've got an NVM drive on, and I'm using on my 4s. I'm using Media MTX for streaming to RTSP.
Cool.
But for the
thank
2,
you guys. Should I close it? I think we're probably at time, right? I don't know what the time
This
is.
is a few questions.
Okay.
If you turn your speaker on, it says annotated. Ask me, but we can turn the audio on to see and ask the question.
Oh, okay. Go
can
ahead.
you hear me? It's Brian here.
Yes.
No, I was just going to say earlier that I've got a Pi 5 and I've got a NVM drive, and that's working very well. But on the cameras, what I'm using with quite a few of my Pis is the Media MTX. I think it used to be called Simple RTSP, but that's to produce RTSP feeds and that then go into Frigate and Home Assistant, etc. But on the Pi 5, they've taken away the 264 encoding, transcoding, what you could do in hardware. So I'm having quite a struggle with actually getting to work with 2 cameras.
Interesting. Yeah, like I said, I haven't. And sorry, I don't want to get the feedback. Thank you for that. Very interesting. Yeah, because I wonder what. So I'll look.
Yeah,
into
you
what
kind of got to.
Yeah,
I mean, what you got to.
interesting. I haven't.
Apparently, the only option is
that much.
Yeah, it needs to be done in the software. I've only just been figuring it out in the last week, but to do the standard, just taking a photo and a short video is fine. But once you want, because I like to have everything streaming via RTSP, so I can consume it in multiple kind of sources. But yeah, the two cameras is definitely not turned out as simple as I'd hoped it for. I hoped it would be, and the normal parameter you add in at the end is H264, whatever is just to force it to use the hardware encoding, decoding. But that's not available anymore on the Raspberry Pi 5, which is, I think it's H265 is available, but doesn't really seem to be used very widely. So good luck.
Yeah, I'll have to look into that because. Yeah, because once you start using the HSV stuff, you definitely need the hardware decoding.
Yeah, the software adds a lot. Yeah, it uses a lot more CPU, of course, etc. But there's something around some of the software people have tried to write. There's some sort of licensing apparently that they're quite worried about with the software 264 encoding. So
got it.
A bit of new territory for me. It was. On even the Pi 0 and the 3 and the 4, it was really easy. You could just run a Docker container, dead easy, did all the encoding and everything. But on the 5, you can't do that anymore, which was new to me. I didn't realize that was a limitation.
Got it. Cool. Thank you.
Cool.
Groovy. Thanks so much.